Think about all the data your company has right now. Your institutional knowledge isn't organized into rows and columns that can be inserted into a database. Creating a vector database might be a great way to find that database. And that's true. But unfortunately, there's a challenge. Existing embedding models are highly specialized to handle certain types of data, images or text. And so if you want to benefit from the wealth of unstructured data you might have, it means you likely have to combine models. But the catch is you can't really combine models because you can't search vectors across different embeddings models because those abstract dimensions that we talked about likely hold entirely different concepts. So this is precisely the challenge that we set out to handle with the new NOVA multimodal embeddings model. Now, this is a state-of-the-art embeddings model that supports text, documents, images, video, and audio. And it converts all of these concepts into a shared vector space, creating a unified understanding of your data. And better yet, the NOVA multimodal embeddings model does this all with industry-leading precision. But now, having a great embedding model is only part of how we're enabling you to use vector search on your data. You see, the real magic happens when the vector search capabilities are available on all of your data, wherever it lives. We've added vector search capabilities to most of our database and analytics services. But we've also asked, what would it mean if we brought the power of vector search to our largest data service? And with S3 vectors, we brought the cost structure and scale of S3 to vector storage. What's great is you can create a vector index the exact same way you can create an S3 bucket. And this enables you to build vector databases of any size with the simplicity of storing data in S3. No provisioning, works at any scale, you pay for only what you use. It's that simple. We're seeing sub 100 millisecond query times with vector databases with 2 billion vectors in production. That's the scale and performance of S3 vectors, and it's going to open up all sorts of new use cases for customers. The response to S3 vectors has been great. In just 4 months since we put it out in preview, over 250,000 vector indexes have been created, and we've ingested more than 4 billion vectors and performed over 1 billion vector searches. As you've heard this week, Trainium 3 will provide up to 40% lower cost than even the most demanding AI workloads. 40% lower cost. That's a big deal when you're spending tens of billions of dollars on infrastructure. Let me show you a little bit more about how we're achieving this. Okay, this is our second generation Trainium Ultra server. An Ultra server is where we combine lots of Trainium servers into a single AI supercomputer. And this second generation is a significant step forward from the first generation we launched last year. Now let me point out a few really cool things. First, this represents our first system where we use all 3 AWS custom designed chips on the same server board. You'll see the 4 Trainium 3 accelerators are located on the far end of the board. And right next to those is a Graviton processor. Now, Graviton gives us the high-speed I/O necessary to keep these accelerators busy. And by having Graviton co-located on the same sled as the Trainium, we avoid the need for a dedicated head node in our rack. And that gives us additional space to build an even bigger Ultra server. Additionally, having that Graviton server there lets us do maintenance on just this one sled without taking the other sleds out of production. And that has the benefit of keeping our capacity where it should be, in production, running your code. And speaking of maintenance, another key differentiator you can see here is everything is top serviceable on this sled. This is unique with an AI server, and this design pays dividends in a few ways. First, it enables entirely robotic assembly of the server, and that lets us put these Trainium chips into our fleet faster. And second, when we need to service these systems in production, we can do it quickly and efficiently. Okay, finally, you'll see that we have 2 Nitro cards to provide very high-speed networking. Nitro enables EFA, or Elastic Fabric Adapter, which enables Trainium servers to share memory over with thousands of other Trainium servers, directly reading and writing from each other's memory over encrypted channels with built-in network multipathing and fault tolerance. Now that's exactly what you need, but we have been working on one more really important thing. That's making it easy for everyone to use Trainium without having to learn a whole new chip and a whole new programming language. And that's why I'm thrilled to share that Trainium is becoming PyTorch native. What does this mean? Well, let me show you. We'll port some code. Okay, here's the code that's running our model on our trusty NVIDIA GPUs. Now, if we change the simple line from to CUDA to Neuron, we're ready to run on Trainium. That's it. That's all it takes. Now everyone, researchers, students, even Dave, can use Trainium without having to run a brand new software stack. Okay, this seamless integration is made possible by phenomenal work from the PyTorch team, allowing us to support different backends. We already have this working with some customers, and we expect to release it broadly early in the new year.